Hello everyone. Today we will discuss about big data. Big data is an important part of machine learning, and also it is a very important part of artificial intelligence. So let's go on. So before moving to our first topic, we should know about what is the learning objective of studying big data. So first we will learn about what is big data, what is the definition of big data, where this big data is used, and what is the origin of big data, and why big data is so much important in AI. Then we will go we will move to the characteristic of big data, where we will know about what are the characteristics, three basic characteristics of big data, that is volume, velocity, and then we will move to our next topic, that is storing, selecting and processing of big data, where we will know about how we will store big data, how we will select the big data which we are going to use in our process, and then we will know how we process the big data for our data model. Then we will know why big data is important, what is the importance of big data. Then after we will move to sources of big data, from where we can find our big data, what is the source where we can get the big data. Then we will move further to tools that are used in big data. Then what is the application of big data, then where the big data is used, and what is the application in IT industry. Then we will know about what is the impact of big data on our IT industries, and then we will move to the future of big data, then how the big data will affect the IT industries and other tech giants in the long run and in the future. After that we will move to the practical relevance of big data. So let's move to our first topic. So what is big data? See, the first that this term, which is known as artificial intelligence, was coined in early 1950s by Professor John McCarthy. So at that time, nobody has any idea that big data plays so much important role in artificial intelligence and machine learning. When the technology, we can say technology developed in a further long run, in that we saw that the data has grown in an exponential manner, and we don't have enough storage to store that data. See, when the artificial intelligence, machine learning programming, and these theorems like Bayesian network theorem and Dempster-Shafer theory, these kind of theorems and theories, when these theories came in existence, at that time we don't have enough storage, and at that time we don't have enough data to we can say prove these theories in a practical manner. So these theories wouldn't work in a practical manner, but these theories were proved theoretically. So now when we can say the data grown in an exponential manner, we didn't have the enough storage to, we can say, store our data, to save our data. Then there came a concept of cloud, where we can store our data. Here the first big data existence, where here the first time the term which is coined is known as big data. So what is big data basically? Big data is basically a next big thing in the IT world. Look, it is similar as small data, which is, we can say, the data of a particular organization, a particular society, a particular hospital. These kind of data are called small data. Now big data is a kind of data which is part of a global organization, like Facebook. Facebook has billions of users. Same, Twitter has number of billions of users, like eBay, LinkedIn, Google. So these organizations have so many, I mean, so much users that they cannot store the data in a small storage, so they stored their data in a cloud storage. Here the concept of cloud come, and here the concept of big data came in existence. So big data is basically a data which is very large in size, that we cannot store it in a device or in some kind of we can say memory. We have to create a large amount of we can say cloud, large cloud to store this data. So Here is the definition of big data. Big data is similar to small data but bigger in size. But having data bigger, it requires different approaches like techniques, tools, and architectures. So this is the basic definition of big data. Now, what is the big data? Big data may well be the next big thing in the IT world. Big data burst upon the scene in the first decade of 21st century. That means in the first decade of 21st century, the big data came in existence in the early 2000s. Now, the first organization to embrace it were online and startup firms like Google, eBay, LinkedIn, and Facebook. These were built around big data from the beginning. So this is how the big data came in existence, and this is how big data is used by some organizations and startup firms. Now, what is the aim of big data? An aim to solve new problems or old problems in a better way. Big data generates value from the storage and processing of very large quantities of digital information that cannot be analyzed with traditional computing techniques. That means the big data, what does big data do basically? It aims to solve a new problems on the basis of old problems. So we can say there is a problem, there is a theorem, or we can say there is a theory given by some computer scientist in 1979 or 1980s, and at that time we don't have enough data to prove that theory, or we can say that theory is applicable only on large amount of data. So what does big data, what is the role of big data in that theorem? The big data basically do that the data which we can take the data from an online organization like Facebook, and the data will be voluminous. That means it will be a large amount of data, like the data of 10 years or 20 years or 30 years of data, and then the theorem will apply on that kind of data, and then after that we will come to conclusion that this theorem is true or not. So to solve these kind of problems, the big data plays an important role. Like here it is written, an aim to solve new problems or old problems in a better way. So what does big data do? Big data generates values from storage and processing of very large quantities of digital information that cannot be analyzed with traditional computing techniques. That means the traditional computing techniques, the techniques of traditional computing, the conventional processing techniques that cannot handle the large amount of data. In that case, we need big data to handle that kind of information, to store that kind of information in somewhere like cloud and some other storage. Now here is the example. Walmart handles more than 1 million customer transactions every hour. And another example is Facebook handles 40 billion photos from its user base. We all know that Facebook has a very humongous user base in the world. So that's why here big data plays an important role. So here is another example, that is decoding the human genome originally took 10 years to process. Look, human genome is very complicated thing. So big data plays an important role here, because human evolution is not today's doesn't happen in one day or 2 day or 1 week, or we can say 20 years or 30 years. It happened millions of years ago. So to decode the human genome, we need big data so that we can achieve it in a less time, and that's what happened. It can be achieved now in 1 week only. So this is the role of big data in our IT firm, also in biotech and other fields. So this is how this is how we use big data in daily life. So here is the example of how big data forecasts the market in US billion dollars. In 2012 it is 5.1 billion, then it is 10.2 billion dollar in 2013, then it is 16.8 billion dollars, then it is 32 billion, 48 billions, and in 2017 it was $53.4 billion US market forecast of big data. So this is how big data is used in the IT giants or IT firms, which is US based. Now, what are the characteristics of big data? Look, big data has three basic characteristics, which is very important. Number one is volume, what quantity of data we are using, and how much amount of data we are using to retrieve some information, to we can say to process something. After that, what is the velocity of data? If the data is very old, there are chances there could be a chances that data will not work properly, or it will we can say work in a very slow speed. So data speed is also plays an important role in a characteristic. After that, what type of data? It could be phenomenal, it could be survey based, it could be data which we have taken from social media or user base of any social media. So what kind of data? What is the velocity of that data? Is it very small data which is very fast to calculate, or we can say which has very high speed? Look, the smaller size of data means the higher speed of data. The larger size of data will work in a slow speed. So this is how the data speed is compared in terms of velocity. Then there is volume, that how much data we are using in the processing of big data. So these are the three basic characteristics of big data. So let's go in detail. Now, first characteristic is volume. The volume of big data means the data should be voluminous. That means it should be very huge amount of data. Like a typical PC might have 10 gigabytes of storage in 2000. Today, Facebook ingests 500 terabytes of new data every day. Boeing 737 will generate 240 terabytes of flight data during single flight across the US. So these are the type of data which lies in the first characteristic of big data, which is volume. That means big data has first characteristic of big data is that data should be voluminous. Data should be of very large amount. That means we will not gonna work on a data of some small organization or some small market. We will go for processing the data of Walmart type of organization. We will search the data from Facebook, and if we are going for like flight company, like here Boeing 737 example has given. So these kind of data is basically known as voluminous data, which lies in the first characteristic of big data. Another example of voluminous data is the smartphones that we are using. They create and consume the very large amount of data on daily basis. So the smartphones, the data they create and consume, sensors embedded into everyday objects will soon result in billions of new constantly updated data feeds. That means whenever you turn the internet connection of your data off and then you turn it on, you can see the numerous number of notifications we can say came to your phone one by one. So this is how we can say the smartphones will fall in the category of voluminous data. See, your single smartphone can generate very big data on daily basis. So big smartphones and their sensors, which is embedded into their everyday objects and other things which we are using in day-to-day life, like your we can say smartwatch and all these things. Even your smartwatch is if you are using fitness tracker, it counts your step, and if you complete your 10,000 step, it will give you a reward or medal kind of something. So this is also lies in the first characteristic of big data, which is known as volume. So a smartphone, a smartwatch, your day-to-day object are now came in the first characteristic of big data, which is called volume. After that, there is second characteristic, which is known as velocity. The velocity of data means that data should be of very high speed. That is, click streams and ad impressions capture user behavior at millions of events per second. Ad impression, that means that advertisement industries which captures user behavior at millions of events per second, which is also called the data. So this is known as velocity of data, which is or we can say it is a very high speed data. So click streams, that is some kind of tool that advertisement industries are using. So these are basically used to capture the behavior of their user on the speed of per second. So this is how we can say big data has its second characteristic, which is velocity. Because without velocity, the industries like Amazon, Flipkart, and we can say eBay, they cannot we can say they cannot give you your preferred order. Like if you have searched shoes on your eBay account or your Amazon account, and then you will see that similar shoes, that similar pair of shoes on Facebook ad paper, or we can say the Facebook ad wallpaper, the Instagram ad wallpaper, and on the other social media sites. So how this has happened? This is what called as user behavior. So this user behavior is basically traced on millions of events, and it is traced on the speed of per seconds. This is why it is important that big data should have high speed. So this is how velocity plays its important role in big data. After that, we can say stock trading marketing, stock trading algorithm. It is the stock trading algorithm. It is a very high frequency algorithm which reflects the market changes within microseconds. We can say market. You see, market is very we can say it is not a constant. Market is not constant. It is changing. It is changing per second. So we can say the high frequency stock trading algorithm reflect market change within every microsecond. So this is how we can say that the second characteristic of big data is velocity, which is very important characteristic. If the big data has not this characteristic, we cannot trace the user behavior using our social media handle. We cannot trace the stock market, the up and downs of stock marketing and stock markets and other things. After that, there is a machine-to-machine process exchange. You see, people are using ShareIt, people are using Facebook, even WhatsApp. WhatsApp is the best example of machine-to-machine process exchange, where we are sharing numerous data every day, in the form of message, in the form of photos, in the form of videos. So we can say machine-to-machine process exchange, the data between billions of devices, infrastructure, and sensors generate massive log data in real time. So we can say we are on our own generating the big data from our personal devices, from our personal mobile phones and our personal laptops, through WhatsApp, through social media, and through many platforms. So this is how we can say the machine-to-machine process exchange has big data characteristic, which is known as velocity. After that, the one and very important example, which is known as online gaming system. See, online gaming system, or we can say online game streaming, is the best example of second characteristic, which is velocity of big data. That means you can take the example of PUBG. There are numerous number of users of PUBG in India only, and we can say that if the PUBG has server which cannot handle such amount of data, or such heavy amount of users, and if it does not have the server which cannot we can say which cannot bear the velocity, or which cannot have the high speed of its data, then it cannot produce multiple inputs per second. So online gaming system should have major characteristic, which is velocity, because the big data on the server of online gaming system generates in the speed of seconds or microseconds. So we can say online gaming system supports millions of concurrent users, and each system producing multiple inputs per second. So this is also a very important part of big data, and it has also a very important characteristic of big data, which is called velocity. So here in these in these examples, in these events, or in these applications, the second characteristics of big data is used, which is called velocity. Now, what is variety? What kind of data we are using? Look, three V's of big data are using. Number one is volume, number two is velocity, number three is variety. That means type of data we are using. The data could be any kind. It could be a geospatial data. Geospatial means the Google map. Look, Google map is the best example of geospatial data. We can search so many users searching the same location at the Google map at the same time. Now, how will Google map generate its output if it doesn't have the velocity, and if it cannot contains the high volume of data in the speed of seconds? So the Google map is the best example of the all three kinds of data set, which of all three characteristics of big data, that is velocity, volume and variety. Big data isn't just numbers. It could be date, strings, it could be we can say survey, or it could be based on phenomena, it could be geospatial data, it could be 3D data, it could be audio, video, unstructured text, it could include log file, even social media platform also lies in the third characteristic, which is called variety. So in the third characteristic, basically that the third characteristic of big data basically says that big data could be any kind of of any kind. It could be in the form of number, it could be in a form of date, it can be strings, it can be geospatial data, it can be a video, it can be online gaming system. So all the data which has produced by millions of users lies in the category of big data. So now, traditional database systems were designed to address smaller volumes of structured data, fewer updates, or a predictable consistent data structure. So the old database systems were like we can say the old Orkut server. These kind of database systems are basically used to handle the small data only. They cannot handle the large amount of data, the millions of data. That's why they couldn't survive in the market. So these are the basic reasons that big data, that if you are handling the big data, your computer or your device should have three characteristics of handling big data, that is volume, velocity and variety. So big data analysis basically include various types of data. Like I have said earlier, it could be geospatial, it could be number, date, strings, gaming, video, games, log files, social media handle, any kind of data. Now, how we will store big data? So before storing big data, we will first need to analyze the big data. So the analyzing big data, that means we will first select the big data from its data sources to analyze it. That means we will select the data source and we will check whether this data is appropriate to store in our data cloud, in our big data storage system. Then we will eliminate the redundant data. See, redundancy means हो गया आपका, redundancy means copying. That means we will copy that if there are many copies of the same data, then we can remove all these copies so that our data could be we can say could not become heavier in size. See, the redundant data is basically a wastage of space. So we cannot handle the redundant data, and we should remove the redundant data, because if the same data is used in a different in the same place and it has no use in our data set, it could become trash, or it can make your system vulnerable. So we will eliminate the redundant data. After that, the third step of analysis of big data is establishing the role of NoSQL. See, NoSQL is application like MySQL, which is we can say SQL server, which is used to analyze your data and which is used for the data characteristics of an organization, the large organization. Like if you are opening some startup and your startup has a very large amount of user base, then in that case you will not go for MySQL, or you will not go for, we can say, the basic SQL server. You will go for NoSQL, you will go for Scala, you will go for Apache Hadoop or Azure Cloud. That's where the role of NoSQL is established for analysis of your big data, or we can say analysis of your data characteristics. After that, we will do the overview of big data stores. See, big data stores. In the overview of big data stores, we will check the data models, where first we will check the key value of data. Now, what is the key value? See, any database, even it is a part of small data or large data, or big data or small data, any database has a key value. It has primary key, it has foreign key. So we will analyze the data characteristics, then we will check the primary keys and foreign keys of that database, and these keys that we will check in the overview of big data is known as key value. After that, we will create the graph of that data. Then the most important work, which is known as documentation of that data. See, in the overview of big data, we will do the documentation, and then we will create the column family, which is basically created in a CSV file or ARFF file using Weka and other things. This is basically part of a data mining. So this is the overviewing of first step of overviewing of the big data stores. After that, we will create a distributed file system. See, distributed system is the most important aspect of big data. The data should be distributed on various devices, and their server should be the one. That means same server, different devices. That means if there is one device which is got trashed, or there is some fault in one device, that in that case our data would not be, we can say, destroyed totally, or we can also recover the data from its checkpoint techniques or data locking techniques. These are techniques of database systems which is using. So distributed database system is used with cloud and other applications like Azure, Hadoop, and these are the examples of distributed database system. Then we will create a HBase, and then there is the most important part of big data store, which is Hive. Hive is basically the basic meaning of Hive means the place where bees are living. So bees are basically in the numerous there are very large number of bees in one hive. So we can say hive is a part where the big data is stored in the final label. So hive is used after the overviewing, analysis, data modeling, and data distribution using Hadoop and Azure, and then after creating the HBase, we will store all the data in Hive. So this is how we can store the big data. Now, how to select big data stores? To select the big data stores, first we have to choose correct data stores based on our data characteristics. Like if our data is in the form of video, and we have stored it in, we can say, text document file, then there are chances that our data could be disturbed, or we can say our data could be trashed. So we have to choose the correct data stores on the basis of our data characteristics to store it. Then what is the code of data? How we have coded the data? What is the background code? And that code is moved to the data, or we can say the data set, and then we will choose the data store, and then we will move that data code to the data set. After that, we will implement polyglot data store polyglot data store solutions. Polyglot data store solutions means one data store, many solutions for that data store. That means one data store can have many solutions, and we will choose the appropriate solution for particular data store for particular data set. So this is how we will implement the data store solution, and then after we will align the business goal for the particular data. Then what is the goal of storing that data store, selecting that data store to store our particular data. If the data is, we can say, YouTube video, then how we will store our data, then where we will store it. If the data is, we can say, CSV file, how we will store, how we will process it, how we will model it, how we will evaluate that data, and the most important is what are the characteristics of that data. So first thing which is very important is the data characteristic to select the store. Then how we could move the code to data. Then what are the polyglot data store solutions we have? That means one data store, many solutions, and it is not necessary that the one data store could have many solutions. If there is one solution, it is sufficient for your big data set. But if there are more solutions, then in that case we have to check the complexity of our processing to we can say select the we can say efficient solution for our data store to store our data in a big data store. And then we will aligning the business goals for a particular data store. So first step is choosing the correct data stores based on your data characteristics. Second step is moving code to the data. Third step is implementing polyglot data store solutions. We have to implement every solution, then we will check which is the appropriate solution for our data set. And after that, the final step is aligning business goals to the appropriate data store. So this is how that we will select the big data store for our big data from any organization, or we can say from any startup. After that, the term which is used is processing big data. See, before processing big data, we should know what is data processing. Look, in data processing, we will process the data, we will remove the redundant values, we will map the data, we will check what is the primary key of data, and we will check if there are more than one same values are used, or many things which we will use in data processing. So data processing is basically the pruning of data, where we will clean the data and we will prepare it for data model. So in big data we will do the same process. Here are the steps of processing the big data. First step is integrating disparate data stores. Here, in integrating the data stores, the steps are: first is mapping data to the programming framework, which is known as data mapping. If there is any programming framework, the programming framework could be from Python, it could be from Java. You can use the framework from Eclipse, it could be from SQL Server. So first is mapping data to the programming framework, then connecting and extracting data from the storage. See, in this stage we will connect and extract the data from storage. See, if there is a server, if there is a, we can say, device where the data is stored. Suppose that this is the data, and this is your system. Then first you will connect your system to that server where the data is stored, and before connecting, first you have to map the data for your programming framework. Like if you are using SQL, the data should be in tabular form. If you are using Java, the data should be in object form. And if you are using Python, In that case, data could be in any form. That depends on your framework in Python. So these things matters if you are using different programming frameworks. After that, if the data is we can say appropriate for your programming framework, you will connect and extract the data from its data storage to your system. Then you will transform the same data for data processing. Like if data is in if data is in form of CSV file, then first you will convert it to ARFF form if you are using on Weka on any server. And then you will use for its further use its further application, like subdividing in preparation and map reducing. So first you will map the data for your programming framework, either it is SQL or Java. Then you will connect from your system to the data storage and extract the data from there. After that, you will transform the data for data processing. Like if it is in CSV form, it is in ARFF form, or it is in Excel form, you will transform the data. After that, you will subdivide the data. You will divide the data in several partitions and prepare it for Hadoop MapReduce, where you will basically reduce the data in several form for the distribution of data, to distribute the data in several systems. Now, how we will employ the Hadoop MapReduce? First of all, we will create the components of Hadoop MapReduce jobs. Then we will distribute data processing across server forms. That means there will be several servers and every server has same data set, so that we can retrieve the data if there is any server which is got trashed due to some problem. So we will distribute data processing across every server, and then we will execute our MapReduce jobs, and then we will monitor the progress of our job flows. So this is how we will process our big data. Now, what is the structure of big data? The structure of big data could be structured, which is traditional data, which is basically historical data. Like if we can take the data of internet users before the launch of Geo, and then we will check what is the dependency of those users on the internet. So these kind of data is known as traditional data, and these kind of data lies in the structured form of data. After that, we will check after that there is semi-structured data. That means that data could be from many sources. Like if we are talking about Geo, the data is from the same telephone. If we are talking about Geo or internet dependency, the data is from the telephone industry, basically we can say network industry. The semi-structured data means that the data, like we can say the data of movie fans in our country. So in our country there are many people who don't like to watch Bollywood. There are many people who don't like to watch Hollywood, and there are people who likes to watch mixed, that means both of them. So these kind of data is known as semi-structured data. That means from many sources we can retrieve our big data. So these two data could be in a form of CSV file, Excel file, in a form of text file. That depends on the system. Now there comes unstructured data. Unstructured data means we have retrieved the data from internet, from various sites, and it could be in a form of audio and video. That means it is not in the form of text, it is not in the form of Excel file, CSV file, or ARFF file. So this kind of data is known as unstructured data. Now, why big data? What is the need of big data? So see, if we are talking about market, if we are talking about IT industries, if we are talking about social media, there is there are numbers of users for the one particular site. If we are talking about only Amazon, there are millions of users is for of only Amazon in India. I'm not talking about world. In India only there are millions of users of Amazon.in. Now, for Amazon, Amazon cannot store the data in some small server, or we can say in one server. It has to distribute its data in several servers, in in many forms, in many servers, and it has to distribute its data, so that if its one server got trashed due to electricity down, power cut, or any kind of fault, it's the company or the organization should not lose its all data of its users. So this is how, this is where the big data is needed. Now, why, what is the growth of big data, and why growth of big data is needed? So the growth of big data is needed because of increase of storage capacities. See, the more users coming in the market, the more storage will be required. So increase of storage capacities means that if there are number of users, millions of users, that there should be the billions of number of storage capacities in our system to store the data. It couldn't be in terabytes, it could be in petabytes or centabytes. So these kind of storage capacities are needed to store our big data. Now, second thing is increase of our processing power. See, we have already talked about velocity of data. So the number of, if there are numerous of users, very high number of users, in that case we have a processing we need very high processing power for our big data server system. Then there is availability of data. That means different type of data for the same system, for the same server. So this is how the growth of big data is needed. This is why the growth of big data is needed for the market, and this is why we need the big data in our day-to-day life, because if there is no big data, we cannot access the applications like Amazon, Flipkart and Facebook and other applications. So this is the need of big data, and this is why we need big data in our everyday life. So here is an example. Every day we create 2.5 quintillion bytes of data. 90% of the data in the world today has been created in the last 2 years alone. That means that 90% of big data, the data means big data, this big data is created only in the last 2 years. Now this shows us how desperately big data is needed for our day-to-day applications like Amazon, like Facebook and Twitter. Here are some more examples why big data is needed. Number one is Facebook, which is the mostly used application since 2010, or we can say 2009. Since that, FB generates 10 terabytes of data on its daily basis. Twitter generates 7 terabytes of data daily. IBM claims 90% of today's stored data was generated in just the last 2 years. And then here it is the, we can say, statistics chart of why big data is needed in our market, and why big data is used by our IT giants. Number one, here is the world population and the connected device. The world population increasing, the increase in the number of connected device. Then there is 7.2 billion world population, and there are 25 billion connected devices in the world. That means one users and many devices. That means one user is storing the same data on many devices. One user can have 2 smartphone, 3 smartphone, or God knows how much. Then there is 7.6 billion world population, and there are connected devices of big data is 50 billion. So connected devices per person is increasing in an exponential manner. As if you take a look here, So the number of devices, the increase in the number of devices indicates that the data which is generated by one user is sufficient, is we can say alone a big data. Is If a single user is generating a big data only, that means the 7.6 billion to store the 7.6 billion users, we have to create a very large storage, a very big storage, to collect the data or to store the data of 7.6 billion users who are using 50 billion connected devices, which is why big data is needed for our market, for our day-to-day life. Now, how big data is different from our small data, or we can say our normal data. Big data is automatically generated by machine, like sensors, embedded engines, and like Twitter server is automatically generate your username and other things. So big data is automatically generated by machine. It is typically an entirely new source of data. That means it could be we can retrieve it from new sources like internet, from process exchange between machine to machine, and it is not designed to be friendly. That means big data could not be friendly. It could be text streams, it could be gaming streams, it could be video, it could be audio. It may not have much values. And look, in big data, basically in big data, there are many part of data which we don't need. So that means if we have collected some big data, that means there is a very big part of data which is not needed for the users, for the, we can say, the person who is storing the data in its server. So that's why may have not much values. So we need to focus on the important part of that collected data, not the whole data which we have collected. Now, here are the big data sources. It could be it could come from users. We can collect it from applications. The big data can come from any servers, any system servers, any device, from machine to machine exchange. It could be generated by any sensor like smartwatch, or we can say smart ring, which is now in common nowadays, like 10,000 steps. If someone has walked 10,000 steps and that device has stored 10,000 steps, so these things are the sources of big data. Then there is data generation point examples. These are the examples of data generation. Number one is mobile device. Then there is microphones, readers and sensors, science facilities, programs and softwares, social media, and cameras. Now, what is big data analytics? In big data analytics, basically, first step is examining the large amount of data. Then basically in the big data analytics, we analyze our big data, where its first step is to examine the large amount of data. Then we will collect its only appropriate information and remove the extra information which is not needed by the server, or which is not needed for the person who is collecting the data. Then identification of hidden patterns or unknown correlations. Then we will check whether it has any competitive advantage. If an IT firm is collecting the data, it will check whether this data has any competitive advantage in comparison with other IT firms. Then it is very useful for that IT firm. So this is why competitive advantage also comes in the part of big data analytics. Then there is better business decision, which means strategic and operational business decisions, which is also a part of big data analytics. Then there comes effective marketing, which is known as customer satisfaction or increased revenue. So this is how big data analytics is an important part of big data. Then type of tools which is used in big data. These tools are, first is the tool where processing is hosted, which means distributed server. Like I told you, that data should be distributed to the several servers, several servers, various number of servers, so that if one server got trashed due to some fault, it could be retrieved from another server. And if there is not any kind of server, the data could be stored in the cloud, like AWS, Google Drive, and these are the examples of cloud basically. So this is how the data is processing is hosted from distributed server and clouds. Then there is where data is stored. So data is stored in the distributed storage. That means the distributed systems where the data is collected, from where the data is retrieved. In that systems, data could be stored, which is we can say there is an example like Amazon S3, and Amazon Web Services provides its own distributed storage to store the big data. So these are the example. This is the example of data storage or distributed storage. Then comes the tool which is known as programming model. See, programming model means how we can create the model of particular big data which we have processed or stored in our servers in our cloud. So it comes there are many processes like distributed processing, MapReduce, Hadoop MapReduce. So these are the example of distributed processing or programming model of big data. Then what are the operations that are performed on big data? See, operations which are performed is big data analytics, and then there is database building, semantic processing. These are the operations which are performed on big data. Now, what is the impact of big data on IT? See, big data is troublesome force presenting opportunities with challenges to IT organizations. That means big data is an opportunity, but it could be a challenge also in some phases. Like if there is a very large amount of data, then there could be a chance that we could lose some of the data, and we cannot retrieve that. So this is how big data is troublesome force. So it is a troublesome force presenting opportunities with challenges to IT. By 2015, 4.4 million IT jobs in big data generated in US itself, and 1.9 million is in UK. Then India will require a minimum of 1 lakh data scientists in the next couple of years, in addition to add data analysts and data managers to support the big data spaces. So this is the impact of big data on our IT industry. Then what is the potential value of big data? See, $300 billion potential on annual value to US healthcare, 600 billion potential annual consumer surplus from using personal location data, 60% potential in retailers operating margins. Then there is a chart here. It shows the annual potential talent pool available for big data in India only. Here is 28 lakhs IT professionals, graduate in maths and science 7 lakhs, engineers, which is the highest number, 50 lakhs. So this is basically this shows the annual potential talent pool for big data in India in various fields, in graduates in economics, graduates in maths, MBAs, PhDs, and graduates in statistics. So this is why big data is is very large talent pool if it comes to India in our future in future. Now, how big data plays an important role in India? See, it is gaining attraction nowadays. Data science is very, we can say, data science is gaining attraction nowadays. People are going for data analytics, they getting trained in data science and R programming and other things. So data science is gaining attraction. Now there are huge market opportunities for IT services in big data, which is basically 82.9% of revenues, and in analytics firms it is 17.1%. Then current market size is $200 million, and by 2020, by 2021 it will be 1 billion. Now the opportunity for Indian service providers lies in offering services around big data implementation and analytics for global multinationals. Now, what are the benefits of big data? The real-time big data isn't just a process for storing petabytes or exabytes of data in a data warehouse. It's about the ability to make better decisions and take meaningful actions at the right time by, we can say, by studying the retrieved data. We can take the decision, we can forecast what will be, what will happen in the future on the basis of present market situations and many things. After that, fast forward to the present and technologies like Hadoop give you the scale and flexibility to store data before you know how you are going to process it. Then there are technologies such as MapReduce, Hive, Scala that you run from, and that enables you to run queries without changing the data structure, which is very important part. We cannot, without changing the retrieved data, we could directly run the same data on Hive and MapReduce. Then on the MapReduce and Hive and Impala enables you to run queries without changing the without even changing the data, or we can say without even changing its primary keys or other things which is contained by the dataset. Then there are other benefits, which is newest research finds that data organizations are using big data to target customer-centric outcomes, which is tapped to internal data and build a better information ecosystem. Then there is big data is already an important part of $64 billion database and data analytics market. Big data basically offers commercial opportunities of a comparable scale to enterprise software in the late 1980s and the internet boom of 1990s and the social media explosion of today. So this is why big data is very beneficial for our IT firms and for startups which is going to start in India. Now, what are the applications of big data? So here are some applications. Number one is smarter healthcare. Number two is homeland security. Then there are traffic control system. Then there is manufacturing, which is very important part of big data, basically manufacturing and marketing and manufacturing. Then there are multi-channel sales, which is we can say Amazon, Flipkart, and other we can say online shopping sites, which uses big data to trace its customers' behavior. Then there is telecom, like Reliance Jio, Airtel is using its the database of its customer. Then trading analytics, like stock markets, I told you. Then the searching quality, that what the number of people, we can say the number of population is searching most, like how Google can tell that this particular person is the most searched person on Google. So this is what search quality is. This is what is called the search quality, and this is the application of big data. Then there is future of big data. The $15 billion on software firms only specializing in data management and analytics. This industry on its own is worth more than $100 billion and growing at almost 10% a year, which is roughly twice as fast as the software business as a whole. In February 2012, the open source analyst firm Wikibon released the first market forecast of big data, which is listing 5.1 billion revenue in 2012 with growth of 53.4 billion in 2017. The McKinsey Global Institute estimates that data volume is growing 40% per year, and it will grow 45 times between 2009 and 2020. And this is what the applications, benefits, and this is how we can use big data in our day-to-day life. Thank you so much for watching this video. My name is Shivhari Tewari. Thank you so much.